The AND gate is a circuit that outputs a logic 1 only when both inputs are 1. Starting from the most basic logic gate will allow us to incorporate it into the creation of a more complex digital circuit later. This is the truth table that shows the behavior of the AND gate for different combinations of inputs. When two inputs are in the off state, output will be 0. The output will also be 0 when neither of the inputs is 0. The output will only be on when the two inputs are on at the same time. Now let's see how we can create this AND gate with artificial neurons using our platform FEAGI. FEAGI is an open source platform that enables neuroscience principles to be used for robotics. To learn more about FEAGI, please check out the link in the description. You can create the two inputs in the AND gate using the Add New Cortical Area feature. For cortical area type, select Custom. You can give the cortical area whatever name you want. For demonstration purpose, I will name this input A to match what we have in the truth table. Here you can select the dimension that you want for the cortical area. For simplicity's sake, we will keep all the cortical areas as 1 voxel. Then you can set the location of the neuron by inputting XYZ values. Before setting any parameters in the neuron, I will create the other input neuron and the output neuron following the same steps. Then I'll connect the two input neurons to the output neuron so we can see how changes in the input can impact the output by adding an efferent mapping here. I will select output as the destination cortical area. Then in the mapping definition, I will choose block to block as our rule. By having PSP multiplier as a positive value, the input neuron will have an excitatory effect on the output neuron, meaning that it will activate the output neuron to fire. Now we will change the parameters within each input and output neurons to ensure our AND gate is functioning as what is stated in the truth table. First, the output neuron is not firing when both input neurons are not activated, so row 1 of the truth table is satisfied. Now let's set the postsynaptic potential of the input neurons and the firing threshold of the output neuron, so our only true condition can work. Postsynaptic potential is how much of an influence that the input neuron is going to exert on the output neuron. In order to have the output neuron to fire when two input neurons are activated, we need to set the firing threshold of the output to be greater than the postsynaptic potential of a single input neuron, and also to be equal to or less than the sum of the postsynaptic potential from both input neurons. I will set the firing threshold of the output neuron to be 100, and the postsynaptic potential of the two input neurons to be 50. Now pressing down the Shift key and clicking on the neurons will allow you to manually stimulate the two input neurons simultaneously. So the last row of the truth table is satisfied. In order to create this behavior of one activated input neuron will not be able to make the output to fire, we have to set a leak constant value for the output neuron. So multiple stimulations from a single input neuron will not be able to activate the output. The leak constant reduces the membrane potential of the output neuron. The leak constant value should be greater than the postsynaptic potential of a single input, but smaller than the sum of the two inputs, since we don't want it to interfere with the other conditions. I will set the leak to be 55, which is greater than the 50 postsynaptic potential we have for a single input. Now our AND gate is all set. Let's see how it behaves again. Thank you for watching.